Hello dear friends, welcome back to my YouTube channel Chemistry Aspirant. Now in today's lecture we are going to learn the statement, example, importance, exception and the limitations to the octet rule. This rule is proposed by the scientist J.N. Lewis. In the previous lecture you already learned about a co-cells and the Lewis approach to the chemical bonding. Link of that video is given in the card. Please check out that video also. Now let us start with the introduction to the octet rule. You know that the electronic theory of valency for the formation of any chemical bond, that is covalent or the ionic bond in a molecule, is mainly based upon the octet rule, which was developed by the J.N. Lewis. Again, from the electronic theory of valency, we know that any chemical bond between the two or more atoms is formed to achieve the stability as like the noble gases or the inert gases by the gain of electron or by the loss of electron or by the sharing of electron between these atoms. As you know, the noble gases are stable due to the presence of 8 electrons in its valence shell, that is in its outermost shell. J. N. Lewis studied the electronic configuration of all noble gases elements and developed a rule which is known as an octet rule. The general electronic configuration for the noble gases is found to be ns2 np6. Now, from the general electronic configuration, the valence shell contains the 8 electrons in each noble gas element. I have given the electronic configuration of noble gases in the table. Now here you observe that except helium, the rest of the other 4 elements such as argon, krypton, xenon and neon, so here they contain the 8 valence electron in its outermost orbit or the valence shell. Hence they are stable in nature. So on the basis of the stability of these noble gas elements, J. N. Lewis gives the statement of the octet rule, which is during the formation of chemical bond, atom lose, gain or share the electron. So its outermost orbit, that is the valence shell, contain the 8 electron to attain the nearest noble gas or the inert gas electronic configuration. Now let us consider the formation of water molecule. The electronic configuration of hydrogen atom will be 1s1. Electronic configuration of oxygen atom will be 1s2, 2s2, 2p4. So from the electronic configuration of the oxygen atom, the total number of valence electron in oxygen atom is equals to 6. Oxygen atom requires the 2 electron to complete its octet. So the 2 hydrogen atom with 1 electron each share their electron with the oxygen atom. Oxygen atom complete its octet in the valence shell and achieve the electronic configuration as like the noble gases neon. Hence the formation of water molecule takes place as the central oxygen atom in the molecule complete its octet. Hence this molecule is found to be stable. Now let us consider the formation of sodium chloride. Sodium atomic number 11, its electronic configuration will be 1s2, 2s2, 2p6, 3s1. Therefore total number of valence electron will be 1. Chlorine atomic number 17, its electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3p5. So the total number of valence electron will be 7. Sodium atom has a 1 valence electron in its valence shell, and it has a tendency to donate the electron and become a electropositive, and it acquires the stable electronic configuration to the near noble gas like a neon by donating its 1 electron, while the chlorine atom has a 7 electron in its valence shell, and it has a tendency to accept an electron and become a electronegative element. To acquire the stable electronic configuration near to the argon, that is atomic number 18, 2,8,8 will be the valence electronic configuration of this one. So during the formation of ionic bond, both atoms complete their octet in their valence shell and the NaCl become a stable molecule. Now let us consider the importance of the octet rule. So the first importance is that this rule is found to be very useful in explaining the normal valency of an element. For example, hydrogen shows the normal valency 1 as it contains only one unpaired electron. Another example, nitrogen atom. Nitrogen atom shows the valency 3 as it contains the 3 unpaired electron. Now the next example, fluorine. Fluorine shows the valency 1 as it have only one unpaired electron. Earlier, it was believed that the normal valency is equal to the number of unpaired electrons present in the atom. Now, let us consider the second importance. This rule is found to be very useful in explaining the combination of atom to form molecule. For example, consider the formation of water molecule. Now, in the formation of water molecule, each hydrogen atom shares its one electron with oxygen atom, and oxygen complete its octet while hydrogen complete its duplet and form a stable water molecule. Okay, now let us consider another example, that is formation of methyl molecule. Now here also the 4 hydrogen atoms share their 1 electrons and forms a stable methane molecule. Now let us consider the third importance of the octet rule. This rule is useful to explain the structure and the stability of the organic compound. You know that you have studied the formation of water molecule, methane molecule and the NaCl. These particular molecule formation, atom gain, lose or share the electrons and complete their octet and become a stable. So that was the stability of this molecule, which is explained on the basis of this octet rule. Now let us consider the fourth importance of the octet rule. Octet rule which can explain the bonding in the different compound. For example, water molecule can be formed by the covalent bond between the hydrogen and the oxygen atom, while the NaCl molecule is formed by the ionic bond between the Na plus ion and the Cl minus ion by donating or the gaining the electron between these two atoms. Now let us consider the exception to the octet rule. Octet rule is not valid for hydrogen and the lithium atoms. These atoms can have only 2 valence electrons in their valence shell, similar to the inert gas element like helium, which is having the atomic number 2 and its electronic configuration will be 1s2, which is actually called as a duplet, and that helium is found to be the stable and it is an inert gas element. Now in the duplet, only 2 valence electrons are present in the valence shell of the helium. Now let us consider the hydrogen atom, atomic number 1, its electronic configuration will be 1s1. It can gain a 1 electron and can achieve the stable electronic configuration as like the helium, that is 1s2. Hence the hydrogen can complete its duplet and it become a stable as like the helium. Now let us consider about the lithium, atomic number 3, its electronic configuration will be 1s2, 2s1. So it can donate the 1 electron from the 2s atomic orbital and can achieve the stable electronic configuration as like the helium, that is 1s2. So it can complete its duplet and become a stable. Now let us consider the limitations to the octet rule, that is drawback or the inadequacies of your octet rule. Octet rule is found to be useful to explain the structure and the stability of the organic compound. But later on it is found that all organic compounds do not obey the octet rule, but still they are found to be stable. We know that octet rule means atom must have 8 valence electrons, but it is found that the central atom in the molecule may have more than 8 electrons or less than 8 electrons in their valence shell, but still they are found to be stable. So here octet rule fails to explain why. Now such molecules can be categorized as having incomplete octet, expanded octet and the odd electron species. So now let us consider the first limitations, that is incomplete octet. Octet rule fails to explain the stability of molecule which having the central atom containing less than 8 electron in its valence shell. That is, they have the incomplete octet, but such molecule is found to be stable. For example, BF3, BeCl2 and LiCl. Now let us consider an example of BaCl2, that is barium dichloride. Beryllium, atomic number 4, its electronic configuration will be 1s2, 2s2. Therefore the total number of valence electron will be 2. Chlorine, atomic number 17, its electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3p5. So the total number of valence electron will be equals to 7. Here The two chlorine atoms share their one electron each beryllium atom and forms a BaCl2 molecule. Both chlorine atoms have completed their octet, but beryllium, the central atom, have only 4 valence electrons in BaCl2 molecule, which is shown by the circle in the diagram. But still, the molecule is found to be stable. So, the octet rule fails to explain the stability of this compound, even though the octet rule is not followed by this central atom in the molecule. Now let us consider the next example, that is formation of boron trifluoride molecule. Boron atomic number 5, its electronic configuration will be 1s2, 2s2, 2p1. So the total number of valence electron will be equals to 3. Now fluorine atomic number 9, its electronic configuration will be 1s2, 2s2, 2p5. So the total number of valence electron will be equals to 7. The three fluorine atoms share their one electron each with boron and forms the Bf3 molecule. All three fluorine atoms have completed their octet, but boron central atom have only 6 valence electrons, which is shown in the circle by diagram. But still, this molecule is found to be stable. Octet rule fails to explain the stability of this compound, though there is having a less than 8 valence electron in it. Now let us consider the second limitation, that is expanded octet. Octet rule fails to explain the stability of molecule which having the central atom containing more than 8 electrons in its valence shell, that is they have the expanded octet, but such molecule is found to be stable. For example, SF6, PCl5 and H2SO4. Let us consider the formation of PCl5 molecule, that is phosphorus pentachloride. Phosphorus atomic number 15, its electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3p3. Therefore, the total number of valence electron will be equals to 5. Chlorine atomic number 17, its electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3p5. So the total number of valence electron will be equals to 7. Now here the 5 chlorine atoms share the 1 electron each with the central phosphorus atom and forms the PCl5 molecule. Now all 5 chlorine atoms have completed their octet, but the central phosphorus atom have the 10 valence electron in its molecule, which is shown by the red circle. Still, the molecule is found to be stable. Octet rule fails to explain the stability of the compound having more than 8 valence electron in its valence shell. Now let us consider the next example, that is formation of SF6 molecule. Sulfur atomic number 16, its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p4. So the total number of valence electron equals to 6. Fluorine atomic number 9, its electronic configuration is 1s2, 2s2, 2p5. So the total number of valence electron equals to 7. Now here 6 fluorine atoms share their 1 electron each with the central sulfur atom and form SF6 molecule. All 6 fluorine atoms have completed their octet, but sulfur is the central atom which have the 12 valence electron in SF6 molecule. But still that molecule is found to be stable. Octet rule fails to explain the stability of this compound containing more than 8 valence electron in the molecule. Now let us consider the third limitations, that is odd electron molecule or species. There are a number of molecules in which the valence electron is an odd in number. It is not possible for all the atoms in such molecule to satisfy the octet rule. For example, if we consider the nitrogen dioxide, that is NO2 molecule, and the nitrogen oxide, that is NO molecule, the central nitrogen atom in both the molecule contribute the 7 valence electron only, but still they are found in nature. So octet rule fails to explain the presence of such molecules in the nature. Now next limitations, that is shape and the geometry of molecule. Octet rule fails to explain the specific shape and the geometry of molecule. For example, methane molecule shows the tetrahedral geometry. Octet rule fails to explain why methane shows the tetrahedral geometry. Now limitation number 5, energies. Octet rule fails to explain the difference in the energies between the molecule. Although all the covalent bonds are formed by the identical manner, that is by sharing of the electrons. Now let us consider the example water molecule, ammonia and the CH4 molecule containing the covalent bond. Now here OH, NH and the CH bond are formed in the identical manner, but their energies are found to be different. So octet rule fails to explain why such happens. Now next limitations, limitation number 6, the nature of noble gases. Noble gases are chemically inert, do not form any chemical compound. However, some noble gases, for example xenon and krypton, also combine with oxygen and fluorine to form the compound such as xenon difluoride, krypton difluoride, or the xenon oxy difluoride compounds, which is found in the nature. So octet rule fails to explain the reactivity of such molecules. Now let us summarize the limitations of the octet rule. So the first was the incomplete octet, expanded octet, odd electron molecule, shape and the geometry of molecule, energies difference between the bonds, and the nature of noble gases. Thank you so much for watching this video. Please do like, share, comment and subscribe to my YouTube channel. See you in my next video.